Today we will be reviewing over the answers, over the review, Unit 5, Part 2 test review. So, what I want you to do today is you're going to work through this review, and then you're going to, after each question that you do, we're going to be checking our answers. Okay, so pause the video, go ahead and do number 1, and then click me back on, and we'll walk through number 1. And we're going to continue that way all the way through this review. Okay, pause the video. Okay, for the first question here, what we're going to do is you need to solve. So first ask yourself, what do I need to do to get the exponential part raised to the x power by itself? In other words, I want to get this 5 raised to the 6x plus a 5 by itself. Well, you're going to say, well, it's already by itself. All right, so the second question you ask yourself is, do you see a log? And you say no. So because you don't see a log, you're going to put a log in there. All right, so we're going to write the log, and because the base of the exponent is 5, I'm going to go log base 5 of 5 raised to the 6x plus a 5 equaling log base 5 of 25. Now remember, 25, as you're doing these questions, keep in mind, 25 is the same as 5 squared. And what is the base of my log? Well, yes, it's 5. So I am going to change this from 25 to a 5 squared. It'll save me a step down the road. Okay, now from here, what do I see? Well, I see this logs out. And it leaves me with 6x plus a 5 is equal to, on the other side, this logs out as well, and that leaves me with a 2. Now I'm going to subtract 5 to both sides. Then I get a 6x is equal to a negative 3, divide by 6, and I get x is equal to a negative 1/2. Of which I put in set builder notation, and I'm going to let you plug that back in to make sure it works, so always check your answers, and there's the answer. Okay, now you go on to question number 2, and pause me, and then turn me back on once you have number 2 completed. For problem number 2, first of all, again, ask yourself, what do I need to do to get this log base 2 of 3x minus 5 by itself? Well, your response is it's already by itself. Okay, so the second question, do I see a log? Well, yes, you do. So I'm going to use that big $10 word, exponentiate, and I'm going to exponentiate both sides. Now, notice the base of the log is a 2. So I'm going to exponentiate with the base of the exponent being 2. So it's going to be 2 raised to log base 2 of 3x minus a 5 equals 2 raised to the 7 power. Now, right here we notice this logs out, and that leaves me with 3x minus a 5 equaling 2 to the 7th. Alright, now 2 to the 7th is 128, so that gives me 3x minus a 5 equaling 128. I'm going to add a 5 to both sides, giving us 3x is equal to 133. Then we're going to divide both sides by 3, and I will get x such that x is equal to 133 over 3. Put in set builder notation, and we're done. Okay, go ahead, pause me again, and you guys work on question number 3. Okay, for question number 3, it says, well, first of all, I have 2 logs. So because I have 2 logs, I need to see how many logs? And if you said 1, you are right. So now we have to remember here, when I have a plus sign in there, that means we're going to do what? Well, yes, plus means times. So it gives us log of 3x times 6. Or I can just write 18x equaling a 2. Now, we do not see a base. That means what type of base do we have? If you said base 10, correct. Okay, so since I see a log, I need to get rid of the log, so I'm going to exponentiate it. So it's going to be 10 raised to the log of 18x equal 10 to the second. Now, this is going to log out, leaving me with 18x equals 10 squared, or 100. We're going to divide both sides by 18, and I will get x such that x is equal to, and now we need to simplify that fraction, to 50 over 9. And there you go. Alright, go ahead and you go to number 4, pause me, finish it, and then we'll look at it here shortly. Okay, for number 4, first of all, again, look at it. Is the this part raised to the 2x by itself? This e to the 2x? No. I have a minus 1 and a 5, and I need to isolate that e to the 2x, so I need to get rid of the 5 and the negative 1. In order to do that, first of all, I'm going to add 1 to both sides. So I will get 5e to the 2x, and that is equal to a 7. Next, I'm going to divide by 5. So I have e raised to the 2x equals 7/5. Alright, now ask yourself this question. Do you see a log? If you don't, what do? Yes, put it in there. Now, what is the base of that exponent? Right, that base of the exponent is an e, which means I want to use a natural log. So I am going to take the natural log of both sides, okay, now this logs out, leaving me with 2x equals the ln of 7 over 5. Now I'm going to divide by 2 on both sides, and that gives me x such that x is equal to, and I'm going to, instead of dividing by 2, I'm going to make it 1/2, so it could be 1/2 ln of 7 over 5. Now, that's my exact answer. If I ask you to give me a decimal answer, remember, you always round it to the, yes, 4th the decimal point, which means you look at the 5th place. If it's 5 or bigger, you round it up. If not, you just cut it off and leave that 4th decimal point the way it is. On the test, guys, unless specifically I ask you to, I want you to leave it as an exact answer. Alright, you go to number 5. Go ahead and pause me. Okay, let's go ahead and begin number 5. Looking at number 5 again, I have how many logs? Yes, 2 of them. And I see it has a minus in the middle. So when you condense it and make it 1 log, because of the minus, what are you going to do? Yep, you said it. It's going to be divide. So it's going to be x minus 1 over top of a 3. Now on the other side, equals to a 5. Now, isolate it. I see ln of x minus 1 over 3. Is that ln of x minus 1 over 3 by itself? Yes, it is. Okay, so ask yourself, do you see a log? Yes, you do. So you're going to exponentiate it. So I'm going to, now what's the base of the log? E. You're right. So I'm going to exponentiate it using a base of an e. So I put an e there, put an e there. Now notice what's going to happen. This is going to log out, and that will leave me with x minus 1 over top of 3 equals to e to the 5th power. Now look here. I have divide 3. What's the opposite of dividing by 3? You're right, multiplying. So I'm going to multiply this side by 3, I'm going to multiply this side by 3. So that's going to give me, let's see, I have this 3 subtracts out, or divides out with this one, and that leaves me with x minus 1 is equal to, and instead of saying e to the 5th times 3, I'm going to use the community property, switch that around, so it's going to be 3e to the 5th power. Now, is it done? Well, no, I have this minus 1 here. How do I get that minus 1 to the other side? I agree, add 1 to both sides. So if I add 1 here, and I'm going to add 1 here, now don't try to take that 3 and add the 1 to it, because the 3 is there beside what? Yeah, it's 3e to the 5th, and this is just a plus 1. So you write it out. So you're going to have x such that x is equal to 1 plus 3e to the 5th power. And there's your solution. All right, go ahead and pause me, and we'll look at number 6 as soon as you have it finished. Okay, you about got that finished? Okay, let's go ahead and begin this one. And looking at this one, is this ln of 2x plus 5 by itself? Yes, it is. Okay, so let's get, do we see a log? Yes, you do. So what are you going to do? Correct, you're going to exponentiate it. So the base of the log is what? It's e. I agree. So you're going to take an e, you're going to exponentiate it with an e there, and an e there. And what's going to happen? Well, this logs out, and that leaves you with 2x plus a 5 equals e to the 3rd power. Now, my next thing I want to do is I want to isolate this x. So I need, what's the opposite of plus 5? Minus 5. Okay, so let's subtract 5 to both sides. So that gives me 2x is equal to negative 5 plus e to the 3rd power. I like to put the constant first in this case. You could have had e cubed minus 5. Either way is fine. Then I'm going to divide by 2. So my final answer is going to be x such that x is equal to negative 5 plus e cubed all over 2. Now, remember, each one of these, remember you want to check your answer, make sure it works so you know that your work is right. And again, I'm going to let you do the checking part of it. Okay, so that handles it for page number 1. Okay, let's go ahead and flip the page, and let's get started on the next one. For this question, you're using the formula APERT. Okay, and we need to look at this, and it says there was a colony of 250 bacteria in a culture growing at an exponential growth rate of 3.4% per minute. Okay, so it says write the exponential growth function for time t. Okay, so pause the video, and I want you to identify the a and the p and the r and the t and write it as an exponential growth function. Now, when I say exponential growth function, that means it's going to be f of t equals what? Okay, go ahead and pause it, and you finish that out. Okay, as you work through this, hopefully you recognized that this here is our P, and this here is our rate, and our time, I see, is going to be in minutes. Alright, so looking at this, f of t is equal to 250, because we started with 250 bacteria, times e, raised to, now we have to take this 3.4, and remember, you take 3.4, you want to, it's a percent, you see that percent there, so you need to change it to a decimal by moving it over 2 places. So it's going to be 0.034 times t. Okay, so that was your exponential growth function. Alright, now from here, it says how many bacteria will be in the culture in 2 hours. Now, notice it says 2 hours, because it says 2 hours, you have to think. Up here, we are in minutes, aren't we? So this t is in minutes. So you have to change, here's a hint, change 2 hours to minutes, and then substitute the value. Okay, go ahead and pause the video and perform that calculation. Okay, let's go ahead and get started here. This is what you should have. So you have, well, first of all, how many minutes are 2 hours? Well, yes, 60 minutes per hour, so 120. So f of 120 is equal to 250 times e raised to the 0.034 times 120. Now, when you enter that into your calculator, if you're using your device, make sure you type it in as in 250 times e caret parenthesis 0.034 times 120, then close that parenthesis. Okay, so make sure you do it that way. If you're using the Inspire, you can just enter it in. Okay. So here's what you should have gotten. F of 120 is going to equal 14786.367. Now it says 36746. Now look right here. We want to round it to the fourth. So you look at the fifth place. It's 5 or bigger, so you round this one up to a 5. So let's go ahead and do that. So I'm going to take this, I'm going to round it up to a 5. So this means, because you always write your answer as a sentence, after 2 hours there will be 14,787 bacteria in the culture. Okay? Okay, that wraps it up for that question. Okay, let's go to the next one. Go ahead and pause me and work through it, and then we'll come back in a few minutes and talk about it. So pause me now. Okay, let's go ahead and begin here looking at this one. It says, in Detroit, we had a population of 910,921 people in 2001. And then in 2011, we had a population of 706,585. So the population is doing what? Yes, it is going down. So that means whatever we get for our K value here, and remember your K is your rate, so same as your R. So whatever we get for this value, it's going to be what? Or it was what? You're right. It was a negative. Okay, so let's go ahead and walk through this one a little bit, and we'll see how you did on this problem. All right, so for starters, what was our initial population? Well, what is our A, what is our P, and so on? Well, the pre-value was this one here. There's our P, and this is our A. And for our T, how much time went between 2001 and 2011? Yes, it was 10. So T is our 10. R we don't know. Now remember, R is the same as our K value, and that is what we're determining. So let's go ahead and plug these values in. So we have 706,585, and that equals 910,921 times E raised to the R that I don't know times time, which is 10 years. All right, now, in doing this one, remember we have to get this E to the 10R by itself. So what's the opposite of timesing by 910,921? Yes, dividing. So that's what we're going to do. So we're going to divide this side and this side by 910,921. And that gives me, now I'm going to just leave that as it is. You know, now that I punch it into the calculator, I do see that that fraction does simplify just a little bit. So I'm going to go ahead and simplify that fraction. So it comes up to be 64235 all over top of 82811. And that equals e raised to, and I'm going to flip that around using the community property, so it'd be 10 times r, or r times 10, whichever floats your boat. Alright, now, look at this here. Is this part by itself? Yes, it is. Okay, so ask yourself, do you see a log? No, you don't. So what are you going to do? Yes, you're going to put it in there. So let's go up here. Let me move over right there. So I'm going to take, now because it's base e, I'm going to take the natural log of 64235, divide that by 82811, so I want the natural log of this whole thing right here, and that equals to the natural log of e raised to the 10 times our r. Okay, now right here, this logs out. And I'm left with, on this side, you have a 10r, and that 10r is on the same level, so let me make sure it looks like it's on the same level, and that equals to the natural log of this right here. Now, if we take our calculator, and let's go ahead and plug that in, and we're going to take the natural log of that answer, and looks like I get, okay, I'm going to get, you know what, before going that direction, I'm going to do one more thing to it. Let me just carry this down so it looks good on the board here. 64235 divided by 82811. Then I'm going to divide this by 10. Now when I divide this by 10, I'm dividing the whole thing by 10, and I get r is equal to, so I'm going to punch this into my calculator and divide it by 10, and I will get negative 0.02540. Now, let's look at the fourth decimal point. Well, here's the fourth one. So I look here, it's 5 or bigger. Nope, it's 0. That's less than 5. Okay, so that means I'm going to just cut this off right here, and there's my rate. Okay, so now what do I do with that rate? Well, it says write the exponential decay function. The function means it's going to be f of t equals, we have our p-value, which was 910,921 times e raised to the rate, and my rate was negative 0.0254 times my time. Okay, so there's our function. Alright, so let's take a look at part C. Part C says use the exponential decay function to estimate the population in Detroit in 2016. Alright, so our goal here is how many years have passed from, yeah, it looks like it was, what, 2001. So how many years have passed from 2001 up into 2016? Well, that looks like 15 years. Okay, so since it's 15 years, we want to find it for f of 15. So we're going to enter this into our calculator. Okay, and let's see what we get. So f of 15 gives us, let's see, 621,321.0863. Okay, so again, looking here, I want to round it there, so I look right there, and I'm going to take that to a 4. All right. Okay. So looking at that, I can see this side right here is very, very small. Okay, so I'm going to just do this. You know, we have like 0.0861 of a person, but you know what? This is one of those situations where we really, that's not much of a person. So we can say in 2016, the population of Detroit will be 622,321 people. Okay? And that does it for that problem. Okay, you go on to the next problem, pause me, work through it, and then we'll look at it together here in a few minutes. Okay guys, I've just noticed something as we're looking at this slide, and I need you to change something on it. You know, look right over here. What do you see right here? You see a 3 there, and you see a 2 there. That should be a 3. So first thing I want you to do is I want you to change that to a 3 to the x power. Okay, so first thing I want you to do is graph the graph the parent function. So f of x equals 3 to the x. Okay, and you can use your graphing utility, or you can just graph it, because you know 3 is greater than 1, which means it's going to be a function that increases, and you know it's going to be asymptotic, and it's going to cross through at 0, 1 right in there, and it's going to kind of go like that. Okay, and the asymptote's right along here. So with that in mind, what's going to happen? You see a -2. So is that a parent? Is that a in the house? So it's a friend. So is it in the house or out of the house? You know. Now, well, just remember, if you have negative x, plus or minus whatever. But well, let me just write this down. Okay. So if I have 3 raised to the x minus h plus k. So this h value that I have right up here, that h value up there, that's in the house, and your k value here, that's your friend. So this is going to move it horizontally. This is going to move it vertically. Okay, so look up here. Does it move horizontally? No, it doesn't. Does it move vertically? Yes, it does. Moves where? Yes, I agree with you. Down 2. And then what happens with this negative x? Well, with that negative x, that means it's going to flip it over the y-axis. Okay, so let's go ahead and play with this here. So what's going to happen? Okay, so let me just get with you and let's do this. So we know it's going to cross right there. We know I have an asymptote that runs right through there. This is the parent function. And you know it's going to do something kind of like this. Okay, so there's the parent function. Now, what's going to happen to it? So let's go to a different color here. I see because of this -2, it's going to shift the whole function down 2, which means now the asymptote is going to be right here at y equals 2. So draw it on there like that and label it y equals -2. And I see it's going to take this point right here, shift it down 2 as well. So it's going to be right there. And the function is going to just be something like that. Okay. Okay, now one more little thing. We have this little negative right there. And that little negative means it's going to reflect it over the y-axis, which means instead of it increasing, it's going to decrease. So the function is going to look like that. And that is our resulting function. That's the final. This here is our answer. Okay. All right. So what was my asymptote? My asymptote, y equals -2. What's the domain? What's the domain of every exponential function? Yes, it's going to be -infinity to +infinity. Why? Very simply because you can be a little person walking along the x-axis here, and can you always look up or down and see the graph? Down here, can you see it? Over here, I can look up and see it. Over here, I can look down and see it. Oh, still look down and see it. If I'm over here, I can eventually go way up and see it way up there, because this continues to go up like that. Okay, so what's the range? Well, the range is going to be from this point up. Okay, so my range is going to be from -2. Oops, I don't want to do that. It's not a bracket. It's a parenthesis. It's going to go -2 to infinity. And what's the translation? Well, it's going to shift down to, it's going to reflect over the y-axis. And one final thing, because of this 3 right there, that means it's going to pull it in just a little bit to the y-axis, so it's going to vertically stretch it a little bit. Okay, so it's going to vertically stretch. Okay, and that's that question. Okay, for this question, you go ahead and pause me here in a moment, but I want you to first graph this parent function and then perform the translations on it. Now, just a little bit of a hint. In this problem, if you have ln x minus the h plus k. So, looking at this, this is in the house, this is your friends, and then things like this out here will affect it. Okay, so go ahead and graph the function and pause the video and answer these 4 questions, and then we'll come back and talk about it here in a few minutes. Okay, so first of all, let's take a look at what this function should look like here. So I'm going to just very quickly sketch this out. Okay, so for a natural log function, it's going to cross at 0, 1 right there. We know the asymptote is going to be right along the y-axis right here, so it's going to be x equals 0. And we know it's going to look something like this and becomes infinitely close to the y-axis. Okay, so we know it looks like this. Now, look up here. If I look here, I see minus h. Is there, now, you know, I'm trying to trick you a little bit. Well, I can't quite say trick, but pay close attention to the way this is written. It says, well, first of all, is there any h value in this problem? Think of it like this. If I were to write ln of x, I'm taking the ln of x. So in a sense, there's parentheses right there, and then it's going to be plus 2. Matter of fact, do I even need these parentheses here and here? The answer is no. You don't need those parentheses. So this is actually what the function is right here. So when you entered it into your calculator, you want to enter it just like this, because your calculator is going to put parentheses, so after the x you close that parenthesis. Don't include the 2 with it. Alright, now when you hit enter on that, you're going to find out that all that happened is this plus 2, that is a what value? That's a k. That's your friends, which means it's going to shift it where? Yes, you're right. It's just going to shift it up 2. So, in looking at this one, where's my asymptote? Well, it's going to be at x equals 0. It's the y-axis. What's your domain value? Well, remember your domain. Look here. If you're a little person walking along the x-axis here, You can look up and see it. Even if you're at a positive infinity, you can look up and see it. But notice as you get close to 0, you don't see it at 0, and for sure you don't see it over here. So that means your domain is going to be from 0 to infinity. And your range, well, now you're a little person walking along the y-axis. You're looking over, you see the graph, you see the graph, you see the graph, you see the graph. Matter of fact, if you're up here, you're going to eventually get over here and you're going to see the graph. Okay, so that means your range is going to be negative infinity to positive infinity. Now, how's it going to translate? What happened to it? Well, remember, I said it shifted up 2. So this point went to here, and it just looks like that. That's all it did. It's still infinitely close to x equals 0. And so we can say that it just translated by moving how? If you said up 2, you are right. So you're going to say up 2 units. Okay, folks, that's going to wrap up this review. I encourage you to, if you need a little bit more practice, keep practicing. Make sure you're good. Test will be next class period. And, folks, that's going to be a wrap today. I will see you in class.